All right, I'm recording. So when the stem and leaf plots, we have tens and we have ones. So when we make the 10 stem and leaf plot, we're going to continue here. So all the 20s, I have to count off all the 20s, which is 28 and 29. Now I count the 30s. I have a 32, a 37. That's it. 2 and 37. 46 and 48.
I definitely added just the number of 55.
And just 55.
Oh, 6, you have 61 twice. No, I definitely not.
61 twice. Any other 60s? No.
And you have 75 and 73.
And 75 and 73.
What did you get when you added all that?
I got 575.
All right, so that's your stem and leaf plot. Remember, you're just organizing. On the test, I put the stem and leaf plot on top because it's smarter just to organize it first before you do everything. So first is mean. So we're gonna add all this and then divide it. Did anyone add it up already for me? If not, I'll add it up. 545. 545. That was not in my room. No, sorry. Okay, so you add up all together, which seems to be 545. Then you get divided by how many numbers you have, which is 11. This should be 49.5. Don't type it wrong then. Mode, we'll do that next. It's just what's the most common. If you have multiple that are most common, you would put both. In this case, it's just 61.
Wait, what if you have none?
None, then you'd be no mode or nothing.
And if there's two reaching numbers, you write both?
Yes. So that's mean, that's mode, and what we got last? Median. The median we're going to use again when we do the box and whisker. So median is going to be in the middle. So we take the numbers and we just count down from the middle. So 28 and 75, which are the biggest numbers. Then we go in the middle again. 49 or 29, 73, 32, 61, 37, 61, 55, 46, which means my median is 48. If you have two numbers in the middle, when you count down, right, you're going to find what is in between those two numbers. And you could do that by adding them, then dividing by 2. But if it's something simple, like what's between 10 and 12, you could just state 11. That's fine. But it's going to be the number in the middle.
You went 8, 5, 9, 3, 1, 2.
Is it mode the middle?
1, 7, 5,
6. Yeah. And just say the whole number when you think about it, so you make sure you don't make a mistake. Go ahead.
Mode is the middle.
Mode is the most common number. Most. So mode most, if you want to think of it like that. So median sounds more like middle to me, honestly. Either way, this is 48. Okay. All right. Next one is the box and whisker. In order to do the box and whisker, oh wait, we need range too.
Wait, what about the Q1?
Yeah, but first let's do range. Range is just the biggest number minus the smallest number. So 75 minus 28, that's going to equal
47.
47. Thank you. So the range is how far it is. Doesn't necessarily going to be close to the mean and median. It could be any distance. 47. Okay. Now that Q1, Q3 comes up in the box and whisker plot. So in the box and whisker plot, we need our minimum number or our smallest number. We need our quarter 1 number or quartile 1. We're going to need our middle number or our median. We're going to need our quartile 3, the third quarter, and we're going to need the max number. The min should be obviously 28 because that's the smallest number you have. And the max should be obviously 75 because it's the biggest number you have. And the middle, we already did the work. So 48. 75, no? Okay. Now, quarter 1, how do you find quarter 1? You're going to count only the half in the front. So I'm going to count from 28 to 46.
Hey, why 46?
Why 46?
Because 46 is before the middle. That's not part of the middle.
Oh, 8 is the middle?
8 is exactly in the middle. It's not in the first half. It's exactly in the middle. So in this case, 46, I'll use red to help out, and 28, 37, and 29.
How do we know like which ones to cross off? I mean, from which sides to go from when you're crossing.
You're going from the edges. So you have to go from the biggest number to the smallest number, then the second biggest number to the second smallest number. So you're going towards to inside. So this,
I don't understand why we got. I just don't get it. It's, you said.
I count, I put my finger here and here, 46 and 28. 46 is the biggest number in the first half, and 28 is the smallest number in the first half. No, you do not include 48 because that's the exact middle.
Oh, because that's the middle of them?
Yeah, that's the
What
middle.
if there's no even middle?
Then you would count the one that's like left of the middle. So,
Or can you just do the average of the two? If there's two middles, then maybe like average.
yeah,
of
but
the-
so the question is,
Three.
I understand what you're asking. Let me answer that question. So let's say, let me just make 1, 2, 3, 4, 5, 6. Yeah. Okay. So in this order, if you wanted to find the middle, it would be in between 4 and 5 or 3 and 4, which would be 3.5. Okay.
What if the fifth one like three numbers? Then what do you do as a middle? Like, what if it's just 1, 2, and 3? What would be the?
2 in that case. And then,
Oh, I'm so dumb.
yeah. And then Q would be, that's a horrible data set because it's only 3 points, but then the Q would be 1 technically because it's, but you don't want to take it like that. But then 3 in this case, this is a good question. 3.5 is the middle. Is 3 the middle? No, so then you would count down from here and then 2 would be your first quartile in that case. But 48 is actually your middle. Because it's actually your middle, you do not count that as your first half. That does not belong in the first half of the data. It's your middle.
Wait, so is the next one like
What's the next one?
61?
Yeah. Because we go 55, 75, then 61, 73, which means what we have left over is 61.
What would you call like this little section? Like, what's the name of the section?
This is the box whisker plot. I think I'm going to draw a blank line here so you guys could just use a straight line, but you got to put the markings yourself. Remember, your markings should make sense. Since I go from 28 to 75, I'll do 20, 30, 40, 50, 60, 70. It's okay if I don't use the whole line. 80. Yeah. Again, you want to make sense. You don't
So
actually,
we have to use all of those to box sequence like follows.
all the numbers have to be represented on the line.
Give us this to fill out. Like,
No, this, you will have this to fill out. You will not have these. You need to know this is part of the box and whisker.
So you're not gonna say like find Q1, I'm just gonna say no to find Q1.
I'm going to tell you to find the box of whisker, which you know, which you should know that needs to be find Q1 and Q3. Yeah.
So I can memorize all this.
Yeah, you have to learn all this if you want to say it like that.
Well, This is tomorrow, I'm gonna.
28. 32, 48, somewhere around here, a little bit before 50, 61, just past 60, and 75 in the middle of 80 and 70. I'm sorry, I didn't realize I'm blocking my head here. All right, with that in mind, I'm going to, for the middle parts, you make a box, and for the end parts, you make what we call the whiskers or just a line.
Is the whiskers part just for like the concept, like you don't actually?
No, 'cause it's
The
measuring
whisk-
range, like
Just
this.
like, no, you're just testing us like if we know like the concept. You don't actually use whiskers.
The whiskers represent something. It
Yeah,
represents the, this would be the bottom 25% of the data, and this would represent the top
Oh,
25%.
people
Wait, so what are the percentages?
This is real data, yeah.
Can you write
Or
the
this is made up data, but this is real use.
Can you write the percentages of each part of the data again?
Sure. So this would be 25%. Each piece is 25%. This is
If you
25%.
took out one of them, it'd be 75% of the rest.
If you took out one of them, it would be 75% of the rest. So this data, Sam, you asked like, what is it used for? This data, what this indicates is that over here on this part, that's longer than the other part, most of your people are on the lower half, and you have some people who earned especially more than the middle.
Like people act like businesses use this for.
Yes, or if you want to, like, if you want to represent like economy or something, right? Like in, let's say, normal economy, you have some people that have, you know, billions of dollars. So the line is really far. And you have some people that have $0. So the line stops there. So then most people though are going to be closer to like, let's say 100,000. But then you have those crazy people who have billions. So the line is really long on the tail end. All right. So that would be your first page of your test. Okay. Second page of your test would have something like this. First, I will give you just a generic one to like make sure you know how to do it. 8C3. By the way, you're free to use your calculator for this also. So 8C3.
Is there gonna be any tests for us here that we're not really doing your calculator for?
I can't answer that. I have no clue. I don't even know what's after this test. Like you're thinking too ahead.
Just like one of our, this is probably like one of our.
10P2. We last test before Passover at least. Okay. So these you can use the calculator, you can do it by hand. I'm going to describe how to do it on a hand. If you don't know how to do the calculator, look it up yourself. I already taught that.
This is combinations of permutations?
Yeah.
You're recording.
Yeah. Does that mean you're not going to pay attention? What do you... Okay, I just want to make sure. For combinations, you have both of them on the bottom, while permutations, you only have 10 minus 2, which is 8 on the bottom, okay? So permutations typically are bigger than combinations. So 8 times 7 times 6 times 5, and I stop at 5 factorial. The reason I do that is because I already have a 5 factorial on the bottom. So I could easily cross that out.
Wait, how did you get from that to like the 8? Can't you just plug it into your calculator?
You could just plug it in your calculator. Yeah.
Do you have one of those like worksheets for like the ones like the word problem ones of these?
Another copy of that?
Yeah.
I have to look on my table. Let me finish this and maybe.
So like, you're okay if we just do it in your calculator?
Yeah, I'm just fine. So 3 times 2 is 6. So I could cross that out, which means this is just 8 times 7, which is 56. Yeah.
90.
And this one is going to be 10. Let me do it black to keep the consistent color. 10 times 9 times 8 factorial over 8 factorial. Hey, the 8's crossed out, so it's just 10 times 9, 80. Again, if you want to do it on your calculator, you're totally free to. These are basically gimmes, okay? 90, because 9 times 10 is 90, you're right. Yeah, I know. My bad. All right. So then do you have the problems where you have to identify which one to use and use it correctly? So for combinations, it's the total divided by the total minus your choosing. So 8 minus 3 is 5. And then the choosing itself, so 3. If you do it in the calculator, you don't have to do that. All right.
When you were going through like school, like did they have it? They're like that?
I know they taught us in calculator, but I think they forced us to do the work, so it's not that tough.
Do you remember how to do like hundreds of formulas?
I would learn what I was needed to learn. Yeah.
No, I'm saying, did you have like a big test, like just to become a? You asking him if he studied for his test? No, like hundreds of formulas, they remember.
Hundreds, I would say that's an exaggeration. No way.
Why was the 6 crossed out?
Because 3 times 2 is. So that's why I just made it a combo. You could have done it top divided by bottom. You could have like done them separately and then divide them. That's fine. But since I'm doing this by hand, I'm trying to reduce as much as possible.
I'm pretty high.
I gotta make up questions over at this part. A game where there is an award given for gold, silver, and bronze. If 10 people are playing, how many ways can people be awarded? Okay.
Ellie, you get all that?
Thank you, Jenna. All right. If 10 people are playing, how many ways can people be awarded? So gold, silver, and bronze, those are particular positions, as in getting first place gets you gold versus getting second place getting silver. They are not the same. So because we're being particular,
We were required to know that.
you need, so it's going to be 10 in total. There's 3 we're choosing, and it's going to be P, because order matters. Getting gold is different, getting silver is different than getting bronze. What were you asking, Sam? Do you need to know?
Gold, bronze, silver.
In the question, we read that. It's gold, bronze,
Are
silver.
we required to know that?
Yeah, you should know gold, bronze, silver. That's general knowledge, I would say. Okay. That's some number. If you have a calculator, you could do it quickly.
Oh, is it peak? Is like specific?
Yeah, you're particular, I say, but particular about gold and silver are different
I
positions.
thought specific was specific.
That's fine. It's like the ocean, right? Yeah.
Probably a high number.
Something that's not particular, like, or actually, let's do this one.
You want us like writing a number out?
No, like after that, it's calculator, do it by hand. Like you proved me in that on the top one, you know how to put it. My focus here is more, can you figure out which one it
Oh,
is?
for the top ones, we have to do them with the formula?
No, I'm just saying like, whatever the number is, whatever the number is, I don't write there. The school is providing a 3-course meal where you can choose from 4 appetizers, 5 meals, and 2 desserts. How many different courses can you make?
I don't know.
Is the weather nice now?
It says CT.
Of course.
Is the weather nice now?
Let me scroll this up.
Go tell the weatherman.
Wait, how do you
I would think it was colder.
I know that.
It could be C, it could be P.
Oh.
The difference between those two is P is very particular in your order, while C doesn't care about your order. But in this question, this is not C nor P. CP. Yeah. What's up? So this one, notice you have 3 categories. You have appetizers, you have meals, and you have desserts. So this one, what we would call it is a counting principle. Now, what is counting principle? We're just literally counting them all by multiplying real quickly.
Wait, is it C, not P?
This is not C nor P. This is counting principle.
So what are you doing in your calculator? What?
You don't do any calculator. Here,
What?
the appetizers, how many appetizers can you choose from? 4.
Oh, this is a new thing?
This is not new. This is a different thing.
It's a different thing.
Yes, this is called counting principle though. There's 5 meals and there's 2 desserts. So you just multiply it because you have 4 choices. Then you have 5 choices they could choose from, and then you have 2 choices afterwards. So it's 4 times 5 times 2, which is 40.
That's all you have to do?
Yeah, you have to set it up like that though. Because someone might think this is a C problem and mess it up everything. Okay?
Why do you multiply? How would that help?
That tells you how many orders you can make. Because you could pick, let's say, the appetizer A, and then you could pick meal A, and then dessert A, then AAB, then ABA, ABB, ACA, yeah. Instead of counting them all out, just multiply.
Wait, why is this counting principle? I don't understand why it's counting principle.
It's counting principle because you're counting each category. So you're counting each category. So you have 4 appetizers. Yeah, this is 3 different type of things. Appetizers, meals, or I should say entrees and desserts. No, because I'm asking about how many ways can it be given. So we're only counting one thing in that case. How many different ways it can be given? Because there's different categories. I'll print out the worksheet and then you can look at it and maybe it'll help you find the listings. What other type of problem will I have?
But like, I don't know, just because like, I don't know, I'm like, I like the paper, I never ever like that.
Next one. Order the letters in the word. What is it? Code. Order the letters in the word.
No, but like, you would like, they're so expensive.
All right, back up here. We're next question. Next question. Ellie, Joseph, Angela.
4 factorial, and then the next one is like.
Okay, first one. This is why this works. Code is going to be 4 factorial. Why is it 4 factorial? Well, I could pick out of the 4 letters, I could pick all 4 of them. Then the third letter, I could pick out of the 3 that's left over. Then 2 left over, 1 left over. So it's 4 factorial, which is 4 times 3 times 2 times 1, which is 24.
1, 2, 3.
No, that's on the next test, whatever that is in the future.
You count first possible.
So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers.
There's 10 factorial on top.
Yeah,
And then you
3
have
factorial.
3 factorial on the bottom.
good. We have a triple of E's. So we're gonna have 3 factorial. And then we also have 2 D's. So we got 2 factorial. So this one, again, you could put it in your calculator, but I would rather write it out because I would rather minimize.
The factorial thing, like, are both those like the same, like, the
Same type of question, you could say, yeah.
Wait, is it divided by like 12?
Is there a factorial?
No, you do not multiply 3 times 2. Oh, but you did 3 times 2 times 2?
I don't know. No, I know. 2 factorial is 2, 3 factorial is 6. And then you have 6 and 2. You type in the number, you add those, and then you.
You could make it to 12, yeah. Yeah. Over 3 times 2 times 1 times 2 times 1. So you could just multiply the bottom, multiply the top, reduce it. I like to reduce before I start. So I see 2 and 2, I cancel that out. And I see 3 and 2, I cancel that out with a 6. 10 times 9 times 8 times 7 times 5 times 4 times 3.
Wait, don't leave it. I just want to do it.
Yeah, just give me the number so then I can just write it out. Extending out, so.
Yeah, 3,000, 300, 302, 400.
Yes, these numbers will get big, so they'll be intimidating if it gets a really big number.
You could rearrange it that many times.
There's that many different orders of rearrangements, yeah.
Interesting. And if you can.
All right, next one.
I want you to.
The probability, we're doing probability, last pages. 300 something thousand? 302, 400?
Ghost is so good.
I liked it like
Uh,
like a minute, and then it got so over, like now I can't stand it. That was crazy.
It's so good.
Okay, probability
1, 2, 2.
of a single die. Probability of getting a 4. Probability of getting less than 4. Probability of getting an odd. Probability of getting, I don't know, 7. Probability of getting, I already did odds, that's the same thing. Probability of giving something bigger than 0. 6. No, you should know a die has 6 sides. But you will ask me in the class and I will answer it'll be 6. That's just something you should know in general.
I don't have common sense.
I think that's information you should.
Adira,
be given in class.
Adira, what's gonna happen? You're gonna ask me during the test, I'll say I'll have 6 sides, that's what okay? Yes, yes, sir.
On the last question, when it was like 10 over 3 factorial, 2 factorial, how did we get 3 and 2 factorial?
3 because we had 3 E's and 2 because we had 2 D's. So any repeats, you got to
Do you not
account for
give me
that.
coin ones? Because I'm so bad.
Coins.
No, the coin ones are the hardest ones.
Really?
Yeah. Because it gets so confusing.
No, the dice
gets No, the dice is the easy one.
No, it gets confusing when there's 2 dice. I don't understand that at all.
Well, somebody should be disappointed whether there's coins or is it gonna be dice. All right. Remember, this is probability, so you don't just tell me how many there are, you tell me out of how many it is. Good. So, guys in the back, So the probability of getting exactly a 4 on a die, there's only one 4 on the die, and there's 6 in total. So 1 out of 6. The probability of getting less than 4. So you have a number less than 4. That's less than 4. I'll put a letter next to it. So n is less than 4. Okay.
1/3.
So n is less than 4. So that's 3. That's 2, and that's 1. So that's 3 over 6.
Wait, if it was more than 4, would it be?
And is
two over
less
six?
than 4?
What's up?
He is less than 4?
Yeah, n is less than 4.
Wait, I wrote 1 over.
Oh, I wrote it. I thought.
Yeah.
I thought it was E.
I'll put a letter here, but it should be n is less than 4. And then n is less greater than 0. I'll put a letter on the test because that I can see where that could get for you.
Yeah, exactly.
Odd. Odd is how many odd numbers you have? You have 1, you have 3, you have 5. So that's 3 out of 6. Again, 1/2. If you want to change the percents, that's fine, but you just leave it as fraction. 7. When you roll a die, there's only 1, 2, 3, 4, 5, 6. There's no way you could get a 7. So 0 or 6, which is 0.
1.
Now probability of getting bigger than 0. 1, 2, 3, 4, 5, and 6 is bigger than 0. So 6 over 6. I understand, but it's 100%. Or 1. Actually, the answer should be 1, but 100% is totally fine also. Of 3 coins. Oh,
I told you I didn't like this.
all the same. Why E equals, no, all the same. Probability of
Do a worksheet for me.
exactly 1 head. I could probably find a worksheet for this.
If you find it, you can do a little question.
I will. Let's see. Probability of, I don't know what else.
2 tails.
Okay. 2 or more tails. Let's do that. And then probability of, let's do no tails. Everyone has the thing on the left, the single die. Does anyone not have it? So I could just put this on a new page. What's up?
No tails is the same as all the same.
What do you mean?
Yeah.
Let's think about that. All the same.
There's no tails, I mean, they're
All the tails means that
They're all the same.
they're all the same.
So what are the results for all the same? Only what?
Nobody could be all, nobody could be all tails for all this.
But I'm saying it's gonna be the same probability.
It's not. Because in all the same, not only you get all heads, what else can you have?
All tails,
So that's how many?
all it's double.
Yeah, it'll be double. So that's 2. Now, the question is, how many out of this total? So when you have 3 coins, you have to use the counting principle to figure out. So the first coin could be 2 times the second coin has to be 2.
What?
And the third coin has to be 2 because you could get heads or tails, heads or tails, heads or tails. Each has 2 tops.
Over 2.
So it's gonna be, no, I just don't know.
It's 6 to 8.
8, right? So there's 8 possible combinations. So it's 2 out of 8.
2, how is there 8 combinations?
So the first coin, how many possibilities are there?
2.
How many coins is on the, how many possibilities on the second coin?
Now have a 1/4 chance.
And then what's the possibility of 2, which is,
2 times 3 is 6.
it's 2 times 2 times 2. It's 2 to the third.
Don't you don't have a, I feel like that's so big.
You think it's not, it cannot be a 25% chance? I mean, we could experiment that, but that's a whole other project.
2 over 8, why?
Maybe that's right before Passover. That sounds like a Passover project, you know? All right,
There's no way it's a 1/4 chance they're all the same.
we could test it out in the future.
2 over 8, you just did 2 times 2 times 2 equals 8.
So that's the total. How many of them are exact all heads though? It's only, are all the same. It's heads, 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 so that's 1 combination, and tails, 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 that's 2 combinations, so 2 over 8.
So it doesn't mean that if we do that 4 times, doesn't definitely come out of one.
It means if we, no, does not mean definitely, but if you did it 1,000,000 times, it should come out 250,000 times. If you did it 100 times, it should be about 25 times. But if you did exactly 4, it would not necessarily mean exactly 1 would be it. That's a different probability. That's a different statistical method or subject about what's the expected versus what happens. All right, exactly 1 head. So what could it look like? It could be heads, tails, tails. Tails, heads, tails.
Exactly one head.
Yeah, tails, tails, heads. So in that case, how many options are there?
3/8.
So 3 out of the total, which is still 8, and then it can't be simplified, so 3/8.
Why 3/8?
What's up?
Almost 50% chance that there's exactly.
What if it's HTT?
Yeah.
What if it's THA?
Would you give us like more than 3 coins for this or would it only be, because I feel like.
Only 3, because after that, after 4, then it's 16 possibilities, and you have to list a lot. All right, 2 or more tails. Now look at this. Well, 2 or more tails, I could get,
Can it be head, tails, heads?
yeah, that's in the middle. Tails, heads, tails.
I have a heads, tails, heads.
You need exactly 1 head. On this one you're talking about? That's 2 heads you just mentioned, yeah. So 2 or more tails.
Set it up in the last one.
You did already set up, or we already did this, so tails, heads, tails. Let me just copy and paste. So this one, and we already did. These are 2 tails. Copy, paste. Do we have any more that could be 2 or more?
Yes.
TTT.
Tails, tails,
All
yes.
tails.
Good, all tails.
So 4/3, 4/8.
4/8, which is
2/3.
1/2.
1/2, yeah. Okay, no heads. What does that mean your coins have to be? Or no tails, I'm sorry.
All
What-
heads.
It has to be all heads.
So it's 1/8.
So 1/8. Maybe we'll experiment on this Wednesday before Passover.
Seems like Thursday.
But then I have to bring a lot of coins. I don't feel like bringing in a lot of coins.
No, this
Yeah,
is
but
a-
everyone's doing it, right?
I'll sponsor you. Coach, I'll bring a coin from my house, don't worry.
Yeah,
Okay.
where's the corner?
Yeah, everyone brings 1 quarter, okay? And then we'll just
I
experiment.
thought it was more of a penny thing, I don't know.
Yeah, flipping coins doesn't work.
What can I get? All that.
Yeah, can I leave a quarter thing?
Quarters?
Yeah.
I mean, NFL does a $50, so you know,
Wait, why would you flip a penny?
pennies are so
I just
small
imagined this being.
and they go out of control if you fling it too hard.
I don't imagine this like.
Yeah, I was expecting this coining question.
All right.
We were on the same.
Yo, yo.
I don't know.
Luckily, it does not matter what the coin is.
What was the, what was the answer to the, yeah, wait, when you go back, when you go back, what was the typing?
Type it here.
4/8.
Where's my typer?
Got it.
Don't give that.
Okay. This is 2 dice. You guys have it already? 2 dice. Probability sum is sum is 6. Probability of a double. The probability of exactly 1 or exactly 1, 2.
I have a funny one.
Probability of
What? Answer me.
the product is
Are these all under probability?
12. These are all in the probabilities, but the scenarios I could give you are all
Same
different.
thing as sum.
No, which product?
What's your
You know.
multiplication?
Yeah.
Oh, that.
Oh, sum of 6 or.
If we run out of time, we also have those marble ones, okay? We also have the marble ones.
Sorry, what?
The ACT ones?
Yeah, the ACT
No,
ones.
thank you.
Actually.
Okay, wait, can you please find an worksheet or make one or something?
I'm not making one, but I can find one. I can see if I can find one, I should say.
Yeah.
What else? 1 and 5, 2 and 4, 3 and 3.
Wait, for the.
What else adds?
My friend Ben
Four and
broke.
6.
Wait, is there anything else on the test except for the marble
4,
thing?
2, 3.
Should be Debbie
I
yet,
don't know any
but I think I
marble
might be running out
ones.
of time. That's why I want to make sure.
Oh, so there is something else? I didn't hear.
Should be nothing else beyond the marble.
3, 2 does not add.
Okay,
But when did we do a marble question? I don't remember this.
okay. Probability is, well, before we start, we need to figure out how many possible orders are there. Their first die, there's 6 of them. And your second die, there's 6 of them. So it's going to be 36. There's 36 in total. All right, the sum is 6. So your dice add up to 6. What could you roll?
1 and 5, 5 and 1.
1 and 5.
4 and 2.
And then you can always do the reverse, 5 and 1, 4, 2, 2, 4, 3, 3. This would be 5/36. Since I'm recording this, I'm just going to keep going. The double. Yes, it could be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So that's going to be 6 over 36, which is 1, 6.
You have it?
Yeah. Wait, I got to put the grade together. Let me finish this. Exactly 1, 2. So that could be 2, 1, 2, 3, 2, 4, 2, 5, 2, 6. And then your second die could be exactly 1, 2. So 1, 2. You only have one. One of the dice have 2. 3, 2, 4, 2, 5, 2, 6, 2. So that's 10. 10 out of 36.
Can you word it better next time though? 'Cause I don't know.
How could I word it better? What do you think?
Exactly one dice has.
Okay, that's
If you
fine.
roll exactly
I feel like you're talking about like 1, 2.
Oh.
Oh, okay. Like 1 and then 2. Yeah. The product is 12. So the product is 12. 3 times 4 equals 12. So 4 times 3 equals 12. And then 2 times 6 equals 12. And then 6 times 2 equals 12. This one will be 4 out of 36, which is 1 over 9.
Do you know if I did okay?
Let me see.
Can I do the marble ones real quick? 'Cause I've done this in-
Sure, I'll do the marbles real quick. Let me just let them copy it down and then I'll let them.
One over 9?
Yeah. 1, 2.
Let's do marble. Wait, I'm doing.
Yeah, write it down. 1, 2, 3, 4. Sit down, Jay. I've just got to answer the questions.
Five. Third one is not. That's what 5 is 12. 3 and 4. You're not multiplying the dice.
Here you are.
I'm asking for products, so you are multiplying the dice.
Multiplying the dice to 12.
Yeah, because I asked for products, so you have to multiply.
Product means like
3, 4, 5.
There's 2 dice. So like,
Oh, it's
6.
that makes sense. Because I was doing the kind of sum. so the
18?
sum makes sense.
Okay, hold up. 30.
Yeah, I did the whole marble thing.
Oh, yeah.
Let me show you what it is.
34.
Actually, you probably won't.
It's a marble that safety collisions.
Alright. Very quickly, marbles. So marbles, marbles. So let's say there is 6 white ones, 4 blue ones, and like 3 greens. Probability of picking a green, probability of picking a red, probability of picking a white, then a white, and then probability of picking a blue, put back white. Right, I'll put in more words, but I'm just trying to quickly.
Okay, so since the total is 13, would be like 3 over there.
Good. So this one, green, you have 3 choices, and then you count how many marbles you have in total, which is 13. So green is 3 out of 13. Red,
No red, so
there's no red, so 0 out of 13.
But
Which
in
is-
the homework, it was like 2, 4, and 6, and then the total was 66.
2, 4, 6.
Yeah, look.
But you have 2 things. Well, look, this one, white and white, right? It's going to be 6 whites over 13 times 5 whites, because I have 1 less, over 12.
There.
So that's where that bottom number gets bigger, because 12 times 13, well, in this case would be, so that if you pick 2 things, it might get bigger.
Both were red, so it's 1 over 66.
Wait, you have to multiply them?
Yes, you have to multiply them, because it's like probability 1, probability 2. So 30 over 1, 56. I'm sure that simplifies to something. And then black, put back white. So black, oh wait, blue, I'm sorry, blue. So that's 4 out of 13. I put back the die or the marble. So now I have 13 again in the total times the whites. So 6 out of 13. 13, that's 13, my bad. So that's going to be 24 over 169. This one you could simplify. I'm just answering their questions with that.
Should I take a test?
No, I'm answering the questions as in for review for the test.
I'm literally so.
You think you should tell me my grade in here?